In this video, I'm going to show you a few more examples of writing force diagrams for fairly simple situations. So for instance, we have a lamp hanging from the ceiling by a rope. And since it's at rest, we're going to say that the acceleration is 0. So our net force is going to end up needing to be 0. So we've got gravity, right, acting down, and we've got a force of tension acting upwards. So we start by making our lamp a dot, and then we're going to draw the force of gravity. Okay, so force of gravity on the lamp by the earth. And then we'll have an equal force of tension. Okay, force of tension on the lamp by the rope. And we should acknowledge that these two forces are congruent, which is why there is no acceleration. So we have a box being raised at constant velocity. So the box is going to be raised upwards, but we're at constant velocity. So again, our acceleration is 0. So our net force is going to be 0. So again, we've got gravity. And we've got a force of tension. So, so here's my box. And we've got a force of gravity on the box by the earth. And then we've got a force of tension on the box by the rope. And again, these are congruent. So notice we end up with the same force diagram for a stationary lamp and a box that's moving at constant velocity, because in both cases the acceleration is 0. A cork floating in water, right? So we're going to have gravity, right? And the force upward is that force that we call a buoyant force. Okay. So again, our acceleration is 0, so our net force is going to be 0. So I've got my cork, and I've got my force of gravity on the cork by the earth. So we've got an equal force upwards, which is our buoyant force. Again, on the cork by the water. Right, and these two are congruent. So now we've got a plane flying level at constant speed. So our acceleration is 0, and our F net is going to be 0. And we've got a number of things kind of acting on this plane, right? So we've got gravity. And then in the upward direction, we have what we call lift. There's a force forward, right? That's from the thrust of the engine. And then we've got a force backwards, right, that we're going to call our drag, kind of like air resistance. Okay, so we've got our plane. We've got the force of gravity on the plane by the earth. And then we have a equal force upward. That's our lift on the plane by the air. Okay, and then we've got a force to the right here. That's our thrust. Remember, this is on the plane by our exhaust gases. Okay. And then equal in the backwards here is going to be our drag on the plane by the air. And these two should be congruent, and these two should be congruent. And that's why we have no net force and an acceleration of 0. Okay, in our last example, we'll use a magnet. We're going to be talking about the iron, the forces on the iron. So there's a force of gravity. Okay. There's also a normal force of the magnet. And then there's a magnetic force. Probably shouldn't have used yellow there, but you'll figure it out. So we'll draw our iron, right? And we've got the force of gravity. So force of gravity on our iron by the earth. And then we've got two forces. So we have another force acting downward here. I'm going to kind of draw it to the side. That's a normal force, right, on the iron by the magnet. Okay? That's just because they're in direct contact with each other. So in the upward direction now, we should have a force, magnetic, on the iron by the magnet. Okay. And since it's not accelerating, we've got a net force of 0. And the two forces downward here together would equal the upward force. Okay? So those are some simple examples of force diagrams.